So for today, we're going to be just going a little further with quadratics. What do we know so far? Well, what could you even do with this? You can't tell the vertex from it, but you could do something. Yes?
You just factor it.
You could factor it. Let's do that. Everybody, if you can factor it, you should. Now, I think one of the biggest mistakes teachers make in teaching factoring is they just tell them to think of these things as just that they're numbers. First, think of the sign. You can think about what sign those numbers are, like plus, minus, you know. Is it even possible that this is a plus and a plus? Is that even possible? No, because we have a negative in our equation. There has to be at least one negative. Now the question is, could there even be two negatives? Is that even possible? There is a right answer for this. Is that possible? Yes. See, some people are saying yes, some people are saying no. Think about it. If you're going to multiply them together and get -7, could they both be negative? No, that's not possible. So then you have to know it's a plus and a minus. Now you can comfortably know that you can put in the things that multiply to 7, which has got to be what? 6 times 1, right? It happens all the time. People like by accident think 6 times 1 makes 7 because they're like adding them in your head. But it's actually 7 and 1, of course. All right. Now, why do we do that? Well, because now we have something called factored form. And that's the new thing for today. Well, you've been factoring forever, but what does factoring form give you? It gives you something special. It does not give you the y-intercept. The y-intercept is where x is 0. It gives you the x-intercept, where y is 0. Do you get if we make this equal 0, then I know x can be -7 and x can be 1. I want to say that again. We are trying to set the x-intercepts, so we put y is 0. All right, copy this down exactly to here. And then we're going to make a bunch of notes out of it. Like, this is how you find the y-intercept. Nope, I'm wrong. The x-intercept. I'm going to come out to check that you're actually writing this down in a second, so be writing it down. That's how you find the x-intercepts. How do you find the y-intercept again? X equals 0. Where could I put x equal to 0? Anywhere you want. If I want to put x equals 0, I could put it here and here. Do you get that's pretty easy then? Y equals what? What does y equal then? -7. So y equals -7. What if I did it in the other form though? Same answer. Even if I put in the 0 here and here, look, you still get -7. That's why these sayings, x-intercept is where y is 0, is way better than just memorizing it's the last number. That's terrible, because then you'll think it's the last number in other forms of the equation. All right, now this one, I have to say the vertex is not super nice. It may have a nice first number, but it doesn't have a very nice second number. But what's the axis of symmetry? By now there's somebody who has memorized the formula for it and will be able to do it. The axis of symmetry. I gave an equation for it. You either memorized it or you didn't. Some people think people's memories are worse than they used to be because we can look up stuff instantly. Like, I really don't need to know my mom's phone number. It's in my phone. But do you get as soon as your phone, like, dies? You just been in a massive car accident and your phone's broken. Now you, like, somebody says, like, hey, can I contact your mom for you? And you're like, I don't know her number. Because you put it in your phone and you don't memorize it. You should memorize an important person's phone number. Some people don't even have their own phone number memorized because, like, they don't ever have to, you know, they can always look it up. The point, there's a few things you should memorize. And nowadays, I say honestly, you guys, your generation, has to memorize way less than I did. I had to memorize tons of stuff because I didn't have a phone that I could, like, store it in. You know what I mean? So I memorized all the phone numbers of all my friends, my own phone number, my address, a lot of things like math facts because we didn't have calculators. So, like, I memorized a lot more stuff. And memory is a muscle. So if you don't use your memory, it gets weak. All right, so moral of the story. You either remembered that x equals -b over 2a or you forgot it. Raise your hand if you remembered it and you had it. All right, good. Now use it. And in one of these forms, it's really easy to tell A, B, and C. And in the other form, it's not easy. I hope you can tell which one to use. Now, this is kind of the haves and the have-nots. Some people know what to do right now and some people don't. This is the formula. In a second, I'm going to ask you to compare your answer to the kid next to you and see what you think that is. X equals what? Okay, compare it to the kid next to you. What do you think? So, would you agree that B? All right, yes, you may use that. But this, you're going to have to stop doing that, or I'm not going to say yes next time. All right, this is negative 6 over 2 times 1. So that's negative 6 over 2, so that's negative 3. Raise your hand if you had negative 3. Okay, what is it? The x-intercept? False. The axis of symmetry, yes. So if you were to draw a graph right now, put a dotted line where this vertex and axis of symmetry must be. Now I slipped and said vertex. It is on this line. And that's what I was going to kind of get to next. There's the line, the dotted line at x equals negative 3. So that's the axis of symmetry. Do you get that somewhere along there, your parabola is going like that? I'm just not sure where yet. All right, so we can find the vertex. We're getting there. We know the vertex has an x of negative 3. Then can't you just go to the xy chart and say x is negative 3? Yes, you can. Do it. X is negative 3. Figure out what y has to be. Use your equations. I don't care. Either one. Any equation that's true. So if x is negative 3, I'd personally use this one. I think it's a little easier. And see what y has to be. Did you get 4 times negative 4, which makes negative 16? Raise your hand if you had that right. Cool. That's the vertex. Now, you should be able to write this equation in vertex form. You've had general or standard form. It's the same thing. It's that one. That was standard form. This was factored form. Now, here's the vertex. You can write it in vertex form. Y equals, do it. Write it in vertex form. You should. That's been on our past homework. In fact, it was on yesterday's homework. Hint, it's got a parentheses like this, and it's got an x, and then it is a parabola, right? So it's got a squared like that. All right, in a second, I'm going to ask you to show your vertex form to the kid next to you, and either you're going to know how to do it or you're not. And if you don't know how to do it, say, can you show me how it works? Maybe both of you are lost. This is not that hard. Here's the vertex. Here's vertex form started. All right, talk to the kid next to you. All right. Opposite of negative 3 plus 3. And then the minus 16 goes out there, and there you go. That's all three forms. That's called what form? Vertex form. What form is this one called? This one's standard form. What form is this one called, where it's got the parentheses? I know it's kind of ugly, but it looked like this. Yeah, that's called factored form. All right, so today's lesson is about factored form, this one. And I do notice some headphones. If you could take those out, please, that'd be good. Because I never can tell if you just forgot them in or what it is. But all right, this tells me the x-intercepts. It's really simple. Some kid might say, yeah, you can't tell the x-intercept from that. And I would say, sure you can, if you set y equal to 0. Then you can tell the x-intercept's really easy. Some other kid might say, well, you can't see the y-intercept easy from this. Okay, maybe not easy, but the y-intercept is super easy too. The y-intercept is where, finish the sentence. The y-intercept is where x is 0. So look, 0, 0. What's the y-intercept? I can do it in 2 seconds. What's a y-intercept? -7. Do you see how fast you can do the y-intercept if you want? You just stick x as 0 in there. All right, so I'm going to give you an equation that's in factored form, as in it's been factored already. And I'd like you to tell me the x-intercept, or intercepts, and the y-intercept. Finish the sentence for me again. The x-intercept is where y is 0, and the y-intercept is where x is 0. Good. I'm going to pause for a second. Let me try that. Good. So if I set y equal to 0, I can find those x-intercepts. Here's the y equals 0 that I wanted. What would make the equation equal 0? And here's a really common way for kids to answer that, and I mark it wrong. You know why? Because they're x-intercepts. So you're supposed to put them in a point where it's x comma y. So let's do them that way. So Vaughn, -4.
0, and 5, 0.
Now you've given me x-intercepts because their y is 0. Alex, the y-intercept is where
X is 0.
Okay, so I'm going to go put in an x is 0. And then you tell me, when I put in 0 here and here, what's this part?
0 plus 4.
So, just what's the total? What does it equal?
-4.
That's just 4. We're just putting in a 0. Just a 0. So then 0 plus 4, don't overthink it, it's just 4. And then how about 0 minus 5?
-5.
All right, so this is 4, and this is -5. What's the grand total?
-20.
Correct. What did we just find? The y-intercept, because we set x equal to 0. See? So the y-intercept was -20. Now, if I just put -20, I'm going to get it marked wrong. How do you say that correctly, Miss Mirtha? That was as quiet as possible, which means you weren't sure, but you're right. 0, comma, -20. The y-intercept is where x is 0, so 0, comma, -20. All right. You with me so far? You feel like you understand this? Okay, so then the only thing that's new for today is that we factor a lot. You already knew how to factor because I made you factor on the first 20 and on the algebra review test there was some factoring. So really this should not be too much harder than yesterday. Let me make sure what you were supposed to know from yesterday. If an equation was like this, you're supposed to go, oh, that's in what form? What form is that in? Vertex form. If you want general form, generally you just multiply it out. And then if you can get the vertex, you could write it in vertex form again, but we already have vertex form. Like, that'd be kind of dumb. So then the only other thing is, what's the other form? Vertex form, general form, and factored form. Can I just factor this? No. And some people think it already is factored, because like, isn't this mean x minus 5 times x minus 5? Yeah, but you can't have another number there at the end like that. That's not factored form. That's vertex form. Because see, these guys are supposed to go together, and then it looks like that, and that is vertex form. Okay, so from vertex form, would you please multiply that one all the way out and tell me what you get, and then see if you can factor it. And then you'll have the trifecta. You'll have vertex form, which is already on the board. You'll have general form, which is what you get after you multiply it out. And then if you can factor that, you should. And you'll have factored form. They all give you different good things. Don't worry if it doesn't factor. Maybe it just doesn't factor. Here's a classic mistake. X squared plus 25. Nope. That's not how you square something. How you square something is by going x minus 5 times x minus 5. And if you made that mistake, you're not alone. A ton of people make that mistake. But the way you get out of making that mistake is by practicing it on the first 20. Do you remember that I sent out an update the other day and said, everybody gets another shot at the first 20? I strongly recommend that you do that over the long weekend. Because why? Because it counts in your grade. It actually counts on this semester's grade. Like, it'll make your grade better if you get a better score. Number 2, do you get how right there, if a kid makes a little algebra mistake, the whole rest of the problem is going to be wrong. They're going to think it's x squared plus 25 plus 7, and they're going to get the whole thing wrong. Okay, so it's going to mess you up if you don't know your algebra. Plus, if you do it a better score on that, you're a little bit better, stronger for your ACT test someday, which helps you get into colleges. Some people hear that, oh, you don't have to do the ACT anymore. That's kind of true. If you want to go to a super easy to get into college, then you don't need the ACT. Man, and there's some places that'll just let you in as long as you have a good GPA. There's some places that you can get into, and you might get into it, but that same college would have given you a big scholarship. That happened to my daughter. She knew she was going to get into NDSU. She was a good student. She knew she was going to get in. But when she showed them a good ACT score, they said, okay, we'll give you this scholarship. And then she got an even better ACT score and sent it in, and they said, okay, now you qualify for this scholarship. So all of a sudden she got like $6,000 in scholarships because she had done a little bit better on her ACT. So moral of the story, the stuff that I just told you to do, the first 20, that'll help you be better on your ACT, which may get you into a better college, and it might get you a better scholarship. So yeah, these things are like super powerful. I bet you there's not a quiz that you could take in your English class today that would get you a better score in their class and make you better on the ACT and better chance of getting into college. It's pretty rare. All right, so I hope you knew this was x squared minus 10x plus 25, but then you got to add the 7. So final answer, y equals x squared minus 10x plus 32. Now, that's good, and that is a different form. It's called standard or general form. I can see something in there. Can I see the vertex in there? No, this is the one I can see the vertex in. But what can I see in this one? Say it if you know it.
Y-intercept.
The y-intercept. The y-intercept is 32. I know that because that's where x is 0. Do you get if I put a 0 here and a 0 here, they just cancel out? Y is 32. So that's good for something. It tells me that. It also tells me A, B, and C. Here's A, here's B, and here's C. Do you remember that little formula? How good is your memory now? I just had you memorize and rememorize a little tiny formula that would tell you the axis of symmetry. Would you please figure out the axis of symmetry for this one? Carter, you remember the formula?
Negative b over 2a.
Correct. It's like the beginning and the end of the quadratic formula. Okay? So the negative b would be negative of negative 10 over 2a, which means 2. So that's really 10 over 2, and that's really 5. And x equals 5. X equals 5 is the axis of symmetry. Couldn't you have just got that from this? Yep, you could have. It would have been faster because you knew that the vertex of this thing was 5, 7. And you could have said, oh, it's just the x of the vertex. All right. Now, I've covered pretty much everything. Is there like something that you might get stuck on your homework? Yeah, if I end this early, then it's very likely there'll be something that'll get stuck on in your homework, but we'd be able to handle most of it. So let's say that the first question, which is similar to this, starts with this. They factored, and it looks like a weird factoring. And I get some people are like, well, I can tell 5 is one of the things that makes it equal 0. But I don't know what to do with this. Well, and that means you don't really know what you're doing. What you're doing is you're setting this part equal to 0. And then you also set this part equal to 0. Maybe you just don't like that you have to take 0 divided by 4. Some people freak out like, that's not real, because 0 divided by 4, you can't do that. No, you can do that all the time. I have no cookies right now. This is true. If I divide that amongst 4 people, how many do they get? 0 divided by 4, which is 0. It's totally okay to have 0. Can I divide by 0? No, it's not a real thing. Can't divide something by 0. It'd be like I have 10 cookies and I have 0 people. Well, that doesn't really divide. You can't divide up your cookies then because there's no people to divide it up amongst. So bottom line, if you have a 0 on the top, it's fine. It's just 0. So this has an answer, and it is x equals 0. That's what makes that part 0. This has an answer, and it's x equals 5, because that's what makes that part 0. So it still has 2 x-intercepts, 0 and 5. Do you get how that's just a little different because the factoring looks different? Here's another one where it's back to normal. A little bit. Now, some people are like, oh, so x equals 3 and x equals, I don't know. Then you don't really know what you're doing. What you're really doing is setting these each equal to 0. And then you just solve it like a little mini bite-sized equation. Solve that one. Not in front of everybody, just do it on your paper. In a moment, I'm going to ask you to share these 2 solutions with the kid next to you. And between the 2 of you, there's 4 names for them. They're called blah. And there's 4 names. There's 4 names for these things. I'll give you one of the 4 names. One of the 4 names for these is they're called the solutions. These 2 answers, x equals 3 and then whatever this solves to be, those are called the solutions, and I can tell by looking at some faces that a lot of you don't know what the other names are for them. See if you can come up with the other names. You were taught these. You'll recognize all of them, but you probably haven't said them in a long time. They're called the solutions. They're also called 4 other things. Hint, think about the graph. All right. Tell them what you think the 2 solutions are, and then what are the other names? Talk to them. Talk to your neighbor. All right, so here we go. They're called, well, first let's get the answer. This one, you just subtract 7 from both sides. And then 3x equals -7. So -7/3. Who had -7 over 3? Cool. What is it? It's a solution, and it's a 0. Yes, that is called a 0. You know why? Because it makes the equation equal 0. So it's a solution. It's a 0. And there's 2 other names. They're going to use these on the homework for today. Find the zeros. That means these 2 answers. The zeros, the solutions, the...
Intercepts.
Really close. What intercepts? The x-intercepts, yes. And there's one more word, and it's used the least, but you will use it in calculus all the time. These things are called the, and it starts with an R. I'll throw it out there that starts with the R. The solutions, the zeros, the x-intercepts, and the... All right, you're learning something new then. The roots. They're called the roots of the equation. I know you might be like, I don't see any root. Well, do you get if this thing wouldn't have factored, we could have used the quadratic formula? The quadratic formula gives you the roots. It has a big square root in it, doesn't it? Now, some of you might think that you couldn't use the quadratic formula because factoring worked. No, we could have totally used the quadratic formula. Now, we're not going to go into that today just because it's like something that's good to know, but we don't need it for today. But this equation would have been 3x squared. I'm just multiplying it out here. And then the outside is 7x, inside is -9x minus 2x, and then the last was -21. That would have been your equation. And if you had to factor it, would you have been able to battle it out and get this? I would have. Would you? Are you good enough at factoring? If you're not good enough at factoring, you could have used x equals -b plus or minus square root b squared minus 4ac all over 2a, and you would have come out to the same 2 answers. they would have just had square roots in them. That would have worked out nice. And they would have come out to this. All right, so when you can't factor something, if you ever get stumped on factoring, I could totally see. I mean, be honest. How many of you would have been intimidated in factoring that one? Some of you aren't being honest. You should have been intimidated. That's hard to factor. But some of you are just really good at factoring. Awesome. But let me just show you. I could have done negative b, which would be the opposite of that. So it's 2 plus and minus the square root of b squared, which is negative 2 squared, which is 4. Minus 4 times a, which is 3, times c, which is negative 21. Holy crap. But it all works out pretty nice. All over 2a, which is 2 times 3, which is 6. And that will simplify down to the two answers we had. It's just gross because you end up with a big square root. But I know the square root works out nice. Because otherwise we wouldn't get a nice simple answer like 3 at the end. All right. And I think it ends up being, let me think, 9, 12, 6 times 6, 18, so this must be 16. It ends up being like 224 or something like that, which is a perfect square. So then it ends up being the square root of 16, which is 4. No, wait. It ends up being 16 as the answer. So it's the square root of something where the answer comes out to 16. Okay, so long story, but that, if you can't factor it, if you can factor it, you should. If you can't factor it, you use that quadratic formula. Okay, so I want to start the homework quiz with you together. Everybody find the homework. It's just a normal little Schoology quiz. And open it up, and you're going to have an inordinate amount of time to work on it. Sure, calls you in. All right, open up that Schoology quiz for homework. Reed, would you read me the first question? I'll come back to you. Vaughn, would you read me the first question?
What are the zeros on the following function? Y equals 4x and then in parentheses x plus 7.
Awesome. I know the zeros. They're the same as the roots. They're the same as the x-intercepts. Okay, so I know one of them super quick, and it's just that this is 0. The other one is that this is negative 7. It's the things that make it equal 0. Those are your answers. Now, be careful, though. If you just type that, 0 in the blank, you haven't given it the right way. So if they're really the x-intercepts, then their y equals 0. So 0 comma 0 and negative 7 comma 0. Does it say like that in the directions, like you got to say it as an ordered pair or something like that? Oh, yay. Okay. Okay. So we're started, and that means you're about halfway done. Read number 2.
F of x equals negative x plus 3 times x plus 5.
And x plus 3 and x plus 5.
That helps. Thank you very much. Like that?
Yep.
Okay, cool. Do you get that's an upside down parabola? Because the negative in front? That means if I graphed it, I know it's going to hit negative 3 and negative 5. Some people think that the negative affects that. It doesn't. X equals negative 3. X equals negative 5. It's just that here's negative 3 and 5, and I know it's an upside down parabola, so I know it goes like that. That's what that negative in the front does. Okay? All right. Because again, if I want to make this equal 0, does it care if there's a negative in the front? If there's a 0 in there, then it doesn't matter if I put a negative in the front. It's still 0, right? So the negative in the front doesn't really do anything. All right, so those are called the x-intercepts, a.k.a. the zeros, a.k.a. the roots, a.k.a. the solutions. And if I had to enter them as points, since they're x-intercepts, that means y is 0. So then you put it like that. All right, this is a work time. And let's see, for today, hold on just a second. You have about 22 minutes of work time. Now, I'd love for you to come up and ask questions, but I would love it even more if your first ask is the person next to you. If they don't know either, then please come up and ask. I want you to really get used to talking to that kid next to you. All right, that's all I have for the video for today.